I know there's one in the mountains.
All right, find your seats. Really? All right, let's get going here. Any questions on the homework? Julie, go put that number. Number.
17, 15, 25, 26, 28, 30.
Pick one. Hey guys, bit too much noise here. Go ahead. Let's take a look at number 17. 17 starts off with 71 minus 5x, and that's equal to 9x minus 13. 9x minus 13. We got variables on both sides. We look at the left side and we say, is there anything we can do on the left side? We look at the right side, we say, is there anything to do on the right side? Kristen, turn around. Nothing to do on either side. There's no distributive property. There's no combining like terms. I do have variables on both sides. My suggestion, is to always get rid of the smallest variable first. Which one's smaller, negative 5x or 9x? Negative 5x. So to get rid of minus 5x, then we add 5x to both sides. Add 5x, add 5x. 5x minus 5x is 0. We purposely did that so it would go away. That leaves me with a 71. 9x and 5x is a 14x minus 13. Add 13 to both sides. 13 is 71 is 84. And that's equal to 14x. And I think that goes, what, 6 times? Is that right? So x is equal to 6.
Mr. C.
Yes.
It was evens, not odds. So
Okay.
17 wasn't one of them.
So there's your bonus plan, Piper. You got to do an extra one all by yourself. Okay, good practice. Yes. Number 6 states the following. 3x is equal to, is it 27 minus something? 27 minus 15x. 27 minus 15x. Hey, anything to do on the left side? Anything to do on the left side? Anything to do on the right side? I got variables on both sides. Move to smaller. Which one's smallest? Which one is smallest? How do you get rid of minus 15x? I'm going to add both sides, plus 15x. 15 minus 15 is 0. We do that purposely so it goes away. We're left with 27. 15 plus 3x is 18x. Okay, I didn't claim this is going to be a friendly answer. Clearly, we got to divide both sides by 18. So I'm going to get 27 over 18, and that's what x is equal to. Just reduce that fraction. What goes into 27 and 18? Okay, 3 goes into 27 9 times. 3 goes into 18. Well, that can be further reduced to 3 goes into both of those, so 3 over 2. Why? Because 9 goes into both of these numbers. 3 and 2. Why are you guys late? Okay, did you ask first?
Too much to change?
Yeah. I'm saying if you're going to be late, let me know. Don't just show up late. Don't show up late. I agree, but you're like 4 minutes after the bell rings, right? So if you think you're going to be late, have somebody come in here and say, hey, Mr. C, there's 2 people changing. Just Alan, let us go late or something like that. But
Okay.
don't just show up late. All right. Good?
Sure.
All right, so it's Friday, and on Friday I collect and I do the grading. So you're gonna collect today. First, move right here.
You good?
I can't have you just turn around.
You look so pretty.
I know. Beautiful. I can play kindergartners, and then we got rolled in basketball. I mean, you see them all.
Again. I'm always green.
All right.
I'm a boss at every point.
So I'm going to give you a warning as you're talking over me, or just go ahead and do what you'd like to do. Okay. Go ahead and continue to do what you'd like to do. Okay, so there's a group of people that have 5 more problems. Continue to ignore me, and things are going to turn out worse for you than they already are. Rylan, you have 4 extra homework problems for refusing to listen. Seriously, your behavior is horrible right now. I know you're in 9th grade. I know you know what you're supposed to do. When you come to class, it's time to learn. It's not time to socialize or sit there talking to the person next to you. It's time to pay attention to the teacher. If this is how you're going to show all of your teachers how much you pay attention, right? There will be some bigger things than extra 4 problems. So Rylan, add 4 odds for you. All right. So your homework tonight is challenging. It's challenging. It is challenging. Thank you.
It's challenging. I think that's everybody.
So word problems in Algebra 1 are never easy. I'm going to walk you through, I don't know how many we'll get to, maybe 4 of them, at least 3 of them. I'm going to walk you through as many as I can in the time that we have. The ones that I chose are ones pretty similar to the ones like for homework. But I'm just going to warn you, this is just like the previous ones we did. You got to be able to read, and you got to be able to logically think through the problem. It's just not randomly throwing numbers down. For those of you who pay attention, you will get this. For those of you that don't pay attention, it will always be an issue. Every single chapter has at least 1 section on word problems. This is this one. All right, so it's called problem solving. It's basically solving word problems. All right, we'll see. So I'm going to do 4 examples, or at least 3 I'll get through. Please try your best. I mean, if you think that you're truly paying attention and you're noticing what's going on around you, you're not paying attention. Pay attention to the board. For some of you, it will be easy. But I'm just going to say, for most of us, when we encounter stuff like this is more challenging work. All right. Here's the model for today's homework. You're going to be given at least 2 statements in the word problem. That means 2 statements that has something to do with some information. You're going to write from each one of those sentences 1 equation. So if you're given 2 statements, you will have 2 equations. And the technique that we'll be using today is substitution. So you're going to get 2 equations. You're going to substitute one into the other, and that's how you're going to get to the answers. So this one will involve a lot of work. Here we go. Hey, it looks like 1, 2, 3 sentences there, yes? It says, find the number of calories in an apple and a pear. Is there a question mark here? So typically, questions have question marks. This one doesn't have a question mark. But it does have a statement that says, declarative statement that says, you find the number of calories in an apple and pear. You're done when you can tell me how many calories there is in an apple and how many calories there is in a pear, according to this information. I said the model was this. You're going to be given 2 statements. You're going to write 2 equations. You're going to substitute. So the first sentence is just, well, that's what the question is. That must mean the next two sentences are the two equations. One is going to be hard, one's going to be easy. So let's see. A pear contains 30 calories more than an apple. The second one says 10 apples have the same calories as 7 pears. The first sentence is hard, the second one is easy. And the reason why I say that is because the first sentence says a pear contains 30 calories more than an apple. Intuitively, the way it's written, guess what you want to write?
X plus 30.
You really want to write x plus 30. It's not. And the reason why is it's comparing what two things? When you compare two things with an equation, that means the left side must equal the right side. That's a problem because this says something has more. So how in the world can we get these things to be equal if one is already more than the other? We're one equation at a time. So step number one, well, we need some variables. What are our variables?
X or A and P.
We could use A and P, X and Y, but whatever we choose, we got to define it. Yeah, let's use A for apples,
And
P for pears. And it's just not A for apples. A represents the number of calories in an apple. P represents the number of calories in a pear. I said the first sentence is the hardest. We're trying to write an equation. An equation literally means that this stuff is the same as this stuff, but that's not what the sentence says. What's the sentence say?
A pear contains 30 calories.
It says a pear has more calories than an apple. That's not equal, that's more. But we need to force it to be equal. I need to force the apple and the pear to have the same amount of calories. How do you do that?
Plus 30 on both sides.
We put plus 30 on both sides, the pear is still 30 more. Because it says a pear is 30 more. So how do you force it to be equal?
Minus 30 on this side.
We're going to use subtraction, but not on both sides.
Just on one.
Think about it. Remember the thing when I said, hey, here's an equal sign, let's just pick a friendly number? Pick a friendly number. 7. We want 7 to be equal to 7. But we're told that if this side is pears, pears have 30 more. This isn't equal now. Oh, no, by the way, we don't know what the numbers are. We know it's A, and we know it's P. And we know that this side is more, it's 30 more. So how do we balance the scale? Right now the scale is like, boom, 30 more over here. So what do we got to do?
Subtract 30.
We got to subtract 30 from this side, and we got to add 30 to the other side. So in other words, what we need to do is we need to write an equation where we're not adding 30, we're subtracting 30. If a pear, right, is 30 more than an apple, then if we subtracted that 30, then they're equal, right? Here's the scale, right? The pears are over here, apples are over here. If a pear weighs 30 more, if I subtract 30, then the scale is even. Isn't that what I just did? There's nothing special that I put the pears on this side. Some people are like, why did you put the P on the left side? Right? I said it was going to be hard. That's the hard part right there. Both equations have to be equal. Well, this is the only way you make that first sentence in red there equal. That's the only way. Who's lost? Does that make sense with the scale thing?
Yeah.
Right? Okay, my first sentence is done. What's the second sentence say?
10 apples have as many calories as 7 pears.
This is the easy one.
So 10A.
So 10 apples have the same number, that literally means equal, have the same as, so what do I write? Was I right? The second one was easy?
Yeah, but
First one is hard, second one was easy.
but don't we have to combine those?
Okay, we just got to get to where we write the two equations first. Yes. Okay, do you understand I got a pear and an apple? Which one's bigger, the pear or the apple, calories-wise? Here's the pear, here's the apple. Are they equal? So how do I make them equal? I subtract something from the pear so that I make them equal. Well, what's the difference between the two? It tells me 30 calories. So if I subtracted 30 from the pear, then they would be equal. That's the hardest part to wrap your head around. And we're just getting started. That's just writing the equations. it says we need to figure out how many calories are in apples and pears. I have two equations and I have two variables. We're going to use substitution. What does this literally say right now?
Apple.
What is it? I mean, just read it. What does it say?
P take away 30 equals 7.
That means anytime I see the letter A, I could. What does an equal mean? I could write, no, we're ignoring this. Anytime I see the letter A, I can write P minus 30, because that's what it says. It says, if you see P minus 30, you're looking at A. If you're looking at A, you're looking at P minus 30. In other words, the first equation is already solved. Solved means just the variable is by itself on one side. So that first equation is already solved for the letter A. Anytime you see the letter A, we can write, hey, I see the letter A, what can I write? I can write P minus 30. So that's what I'm going to do. This is the substitution. You're going to take what's in red here, and if you see the letter A, you're going to write P minus 30. Well, second equation says 10A, so I'm going to write P minus 30 where there's a letter A. You're like, well, how's that going to help me? Notice how many variables I now have. I can solve an equation with one variable. This whole chapter was solve equations of one variable. Okay, well, I can solve this. Tristan, what do I do first? What do I do first?
10 P's.
Keep talking.
Minus.
Tell me what to do mathematically. What are you trying to get me to do?
Distribute.
Distribute. Perfect. So you distribute the 10 to the p, you got 10p. Now what are we distributing? Okay, times negative 30, that's negative 300. Yes? Could you solve that equation now? Two-step equation. So add, well, oh wait, got variables on both sides. Move the smaller of the two. Which one's the smaller of the two? So how do we get rid of 7p? Subtract 7p from both sides. Can you do that in your head? We get 3p minus 300 equals 0.
You have to do.
All right, so
Bring the 10 to 10p to the other.
no, we're already done with that. We moved the 7p to the other side.
My math teacher did it different.
You can, but then you get a negative, and I don't like negatives.
Yeah,
Right?
he told us that if there's one equation on one side, we can't take that one away. We have to.
You can. You can always do that. Right?
I always thought that we were never allowed to do that.
She might have been talking about something else, but this one you're absolutely allowed to do that. You can't ever divide by 0. You can do, add 300 both sides, and you get. Therefore, p equals. How much?
100.
What? I'm trying to get a bunch of people said the right answer. P equals.
100.
Hey, are we done?
Yeah.
No, we're not. What's it say?
Add 30.
Find the number of calories in. What did we just find? So how do we find the apples calories? We go back to the original equation, which says take the letter P, which we just figured out is, and you subtract 30, and that's what A is.
How did you get rid of A? What is
This is called substitution. When you have two equations, and one of them is already solved for one of the letters, either A or P, you can substitute its result into the second one. This says A is literally P minus 30. So anytime I see the letter A, I can write P minus 30. So like I see an A right there. I wrote P minus 30. This is 10A equals 7P. The reason we do that is because I can't solve an equation with two letters. I can only solve an equation with one letter. So I originally started off with two equations with two letters. Through the process of substitution, I get one equation with one letter. For those of you like, wait a minute, there's a P there and a P there. It's the same letter though. Then I can solve it for that one letter and then resubstitute it back in to find the second letter. We're going to do 4 of these. They're all basically the same. So hold your, I'm a little bit lost here until we get through about 2 of these. Okay? Ready? Let's do another one. Oh, by the way, we've got a substitute back in there. 100 minus 30 is 70, so 70 calories for the apple. I don't know if this is true or not, but it looks reasonable. I mean, I know the math is right. I just don't know if apples really have 70 and pears have 100. All right, number 2. Okay, if you're sitting there doing nothing and writing nothing on their paper, you're not being a good student. All right, here we go. The technique is the same. You're going to have 2 sentences. You're going to get 2 equations. You're going to do substitution. Okay? Find the number of full 8-hour shifts that Maria worked last month. She worked twice as many 6-hour shifts as 8-hour shifts. She worked for a total of 280 hours. The first sentence is what?
Twice
Is
as
it the
many.
question, or is it what are you trying to figure out? What am I trying to figure out? I want to find out how many 8-hour shifts she worked last month. Okay? That means the next 2 sentences are my 2 equations. There's going to be a hard one and an easy one. First one's the hard one. All right. So variables. I mean, shifts, there's an 8-hour and a 6-hour. They're not really letter. There's no real good letter to use for each one. So I'm going to use X for the number of 6-hour shifts and Y for the number. There's nothing special about those letters. X is 6, Y is 8. Now, where did you get that from? Well, the second sentence is 6-hour and 8-hour shifts. Nothing special about X and Y, they're just letters. So we're going to do one sentence at a time. The first one is just the question. The second one is the statement. It's the hardest one. Once again, I need an equal sign. It's a balance. I need this side to be exactly the same as the other side. It doesn't say she did the same number of 6 hours as she did 8 hours. What does it actually say?
Twice as many.
So if it's twice as many, is it balanced right now? One of them is twice as many as the other. It's heavier. Well, how do I make them equal?
Divide.
So you would think as it's written that you would multiply, right? Because this is twice as many. But in fact, you need to get rid of this weight so it balances.
So you divide by 2.
So you need to divide, but which one by 2?
8.
Which one do you have twice as many as?
6.
Okay, so it says you work twice as many 6 hours. So there's 2 ways of thinking of this. We either could divide the number of 6 hours by 2, or we could, what's the other way of balancing it?
Multiply by 1/2.
Make this one heavier.
Or
Well, how would you make it heavier?
8 times 2.
You'd multiply by 2. So there's 2 ways. What do you like, multiplying or dividing? Most people like multiplying. So which one are we going to multiply to make them equal?
8 times 2.
We're going to multiply the 8. Why? Because there's twice as many 6-hour shifts. So we need to multiply 8 hours. Which letter is 8?
Y.
So it's going to be 2y is equal to x. 2y is equal to x. This is the hard, I mean, that's the hard one, and that's the one that you'll mess up. Because it doesn't read that way. It says twice as many 6, so you really want to write 2x equals y. It's not balanced. It's too heavy. You either got to divide this side by 2 or multiply. We like multiplication way better than division. All right, we're done with our first one. I said the second sentence would be easy. She worked a total of 280 hours. Well, what would that mean? Something equals 280. What equals 280?
2 times Y equals 280.
Well, what does x represent?
6.
What does it represent? Not 6, but
Number.
the number of 6-hour shifts. What does y represent?
Number of 8-hour shifts.
So how do we get to 280? Well, x plus y would be an unknown number, but x plus y doesn't include the fact that x represents 6 hours and y represents 8 hours. So this is an easier problem. You got 2 pieces of candy. This one costs 10 cents, and this one costs $1, right? And together, the number that you bought adds up to $2.80, right? So you take the number of pieces, you multiply it by this. You take the number of pieces, you multiply by this, and add them together. This one's 6 times x
Yeah, 6 times X.
plus
Y.
8 times y, and that's going to equal, where am I getting that from? Because this is 6 hours. How many did you have? I don't know. That's what we're trying to figure out.
Get it.
This is your 8 hours. How many did you do? I don't know. That's what we're trying to figure out. But I do know if I work 2 8 hours, it would be 2 times 8. If I work 3 6 hours, 2 times 8 plus 3 times 6, and together that equals 280. Okay?
How do we combine them?
Okay, so we're going to use this process called, click you, substitution. One of these equations is already solved. Which one? Hey, this says wherever you see the letter X, we can write. So let's go to the second one, and anytime I see an X, I'm going to write 2y. Hey, I see an X, so I'm going to write
2y.
See what I did? I see an X, so I'm going to write 2y. What allows me to do that? Because the first equation literally says X is the same as 2y. Chris, there should be pencil moving. Now this looks ugly, but we can solve this. The reason why we can't solve that is because it has 2 letters in it. It's got 2 letters. The best you can do is get one variable by itself. The other side is still going to have a variable. But when you only have one letter, y, we can actually get y equals a number. Hey, anything to simplify on the left side here? What?
8y divided by 8y. None.
How about we do the multiplication first?
Oh, I forgot you can multiply. Oh, yeah.
So what do you get here?
12y.
You get 12y. Hey, how about we just group them together? They both say y, right? So group them together. What do you get? I don't want to go too fast, but we group them together, you get. And then the last step would be divide both sides by 20. What's 280 divided by 20? Close, but no. 14, right? We okay? So what did we just figure out? So we know the number of y shifts. Well, y represented 8 hours. Is that what the question asked?
28 equals x.
Well, I don't know. Does it ask us how many 6-hour shifts she worked? Does the question ask how many 6-hour shifts she worked? Hey, then we're done. Most of the time, the question would say, tell me how many 8-hour and 6-hour. This particular one doesn't say that. So we're actually done right here. So the process is, you're going to have 3 sentences or thereabouts. 2 of the sentences will give you 2 different equations. You do the substitution thing and you do some solving. Occasionally, you got to resubstitute this back in. And by the way, we could figure out how many 6-hour shifts. If y is equal to 14, how many 6-hour shifts did she use? If y equals 14, how many 6-hour shifts did she pull? 28. And it does say she worked double the number of 6 as 8. Okay, there you go. Well, that's 2. Is that what your eyes are doing right now?
Yes.
Okay. Oh my word, look at all those words. Okay, so it looks like we have boxes of pecans and walnuts. All right, it says that the box of pecan are placed in boxes and those boxes weigh 3 pounds. It says the boxes of walnuts are placed in boxes and those boxes weigh 2 pounds. It says there's 24 fewer 2-pound boxes than 3-pound boxes. And the total weight was 426. It's a combination of the first example and the second example. Okay, so step number 1, we need variables. What's our variables?
P and W.
P and W. Okay, so P is going to be the number of boxes of pecans, and W, I used X and Y, assuming. Right? Cool? All right. First sentence is hard, or the first equation is hard, the second one is easy. Once again, it's a balance. Right? Does it say they literally weigh the same amount?
No.
It says there were 24 fewer walnuts. Okay, walnuts over here, right? Pecans over here. It says there were 24 fewer. That means there's more pecans over here. How do we make them equal? You subtract, and this gets even, I'm sorry, if you subtract, this gets higher. So we need to add to which one? The one that we have the least of. Which one do we have the least of? It says there were 24, where does it say? There were 24 fewer walnuts boxes. So we need to add that to the walnuts in order to make them equal. Which one is walnuts? Walnuts is Y. So what are we going to do?
Y plus 24.
Y plus 24. It doesn't read the same way it writes. It's, I don't want to say it's the opposite, but it kind of is. But this thing I'm doing with my hands about a balance is how you kind of wrap your head around what to do. Well, that's an ugly equation. Maybe the second sentence is easier. It says the total weight. How do you get total weight?
Equals multiplication.
Well, how do you get a total weight?
Adding.
You add. What are you adding?
20. I don't know.
What are we adding? By the way, it equals 462.
Pecans and walnuts.
Okay. How many boxes do you have, though?
24 fewer.
I don't know.
24 fewer.
Doesn't tell me that.
W plus 24.
Okay. But I do know that how much each box of pecans weigh. How much does each box weigh?
2 and 3 pounds.
I do know how much each box of walnuts weigh. How much, Julie? How much does each box of walnuts weigh? If you're not looking at the board, you're not with me. How much does each box of walnut weigh? It says it.
2 pounds.
Where does it say it?
I mean,
It says it right here. 2 pounds is a walnut box. It says it right here. I even made it in red. Come on, stay with me. 3 pound boxes of pecans. So how much do walnuts weigh, or box?
no.
You seriously don't see it? No one sees it?
Wait, say it one more time.
How much does a box of walnuts weigh?
2 pounds.
How much does a box of pecans weigh?
3 pounds.
Okay, well, how many boxes of each do you have?
We don't know.
That's the thing you don't know. That's why we have a variable.
Okay, so.
So if you want to know how much do all the boxes of walnuts weigh, well, not X plus what, just walnuts. How much do all the boxes of walnuts weigh? Well, I don't know. How many do we have? Y. So I take Y to multiply it by. I got boxes of walnuts. Each one of these is a box of walnuts.
Yes.
Each one weighs what?
2.
So how much do they weigh? There's my boxes.
2 times.
1, 2, 3, 4. Right?
2 times.
So it's 2 times Y, because Y represents how much of the walnut weighs. What do I do with the pecans?
3 times.
3 times how much one of them weighs. I mean, 3 times how many you have of boxes. So there's your equation. 3 represents how much pecans weigh. How many do you have? I don't know. It's X. 2 represents how much of one box of walnuts weigh. How many do you have? I don't know. It's Y. We have 2 equations now. One of the equations is already solved. Which one?
2. No.
Which one is already have one letter on one side all by itself? Which one? This one is already solved. It says literally X equals. So I take the first one. First one says if you see the letter X, what can you write?
Y.
Not Y equals.
Oh, plus.
If you see the letter X, you can write Y plus 24. Hey, do you see the letter X? So what can you write?
3 plus.
I can write Y plus 24. So let's do that. This is the substitution. So I take this second equation right here. I see the letter X. I'm going to write Y plus. Why Y plus 24? Because the first equation told me that if you see the letter X, you can write Y plus 24. Okay, a little ugly, but we can handle this one. First step. Okay, distribute property, right? What do we get?
3Y.
Plus a big number.
60.
72, is that right? Is that right?
Yeah, that's right. That's
Okay. Anything else to group together?
The 3Y.
Okay, so 3Y and 2Y, that would give me. Are your eyeballs on the board? They're not, they weren't a second ago. Okay, so that gives you 5Y. Where did 5Y come from? 3Y and 2Y. Now it's just a 2-step equation, an ugly one, but could you solve this? Okay, I will solve it for you. I just got to everybody, could you solve this? Okay, I'll give you the answer. 78 boxes. Did we just answer the question?
Part of it.
What's the other part?
You have to find out how much Y X is.
Okay, well, it says X is 2Y plus 24.
So
So what do I do with this?
78 plus 24.
I take that and throw it back into that equation for the letter Y, because it says Y is 78. And just, it says add 24, and then that gets you what X is. So it's a second substitution. You won't do this all the time, but a couple of them will ask for both answers. When it's asking you for both answers, you got to do substitution. All right, you tell me, easy or hard?
Hard.
This is hard. This is hard, right?
Brain hurts.
The idea of me with the balance thing, because I'm going to tell you, once you get past the first equation, the rest is easy. Well, It's calculations. But I'm saying the rest of it is relatively easy. But getting that first one balanced is the hard thing. It can't be, you can't just write it the way it reads, right? You have to think and make sure it makes sense, that it remains balanced. All right, so with exception of Rylan, everybody else has what for homework?
2 through 33.
Okay. And Rylan, you add another 4. Do 4 of the odd ones.
Yeah, I did.
Okay, that's it. Go to lunch.
Oh, really?
Wait, did I mess up?
No.
Yes, I did.
No, you didn't.
That's wrong.
No, you didn't. You didn't mess up.
All right, just chill out for a couple minutes. It's 2 minutes after that second bell, right? No, I think it's like 2 minutes after the second bell.
Yeah, that's when they go up.
Yeah, no, but that's when 2 minutes after the second bell, our bell rings. So we're close.
Did you go to the restroom?
Sure. Hey, Julie, you paid no attention in class today. Congratulations.
I did pay attention.
Looked like you were falling asleep. Your eyeballs were.
No, I wasn't.
If you had written a message on your eyes, I would have.
I took all the notes.
All right, we got 2 more minutes. 2 more minutes. Well, yeah, in a second or two. Rowan, you have to come back in after you go to your locker. All right. You guys are locker crazy today. Hey, Haley, this is going to be hard homework. Give
Yes,
it a shot. All right. Have a good weekend.
I already tried giving the first one a shot, and I had a difficult time with it. So I think I'm going to try it the best I can and then ask you on Monday for help.
Sounds like a good plan. All right. Have a good weekend.
You too.